Okay, on to question 10, and we're now on to similar shapes and the effect that causes on length, area and volume. Okay, I'll show you this both two different ways. So something I often like to do is start off by writing down length scale factor, area scale factor and volume scale factor. And hopefully you know how these things are related. The length scale factor obviously just describes what we've multiplied lengths by to get new lengths. Now in this case we've multiplied by 2, we've doubled the height. Now the area scale factor is going to be the length scale factor squared, okay, which would be 4, and the volume scale factor, I don't know if volume's involved in this question, don't think so, but it would be the length scale factor cubed, which would be 8. Okay, and now that we know the area scale factor, we can work out the area of shape B, because we were given the area of shape A. So we just need to do 20 times 4, because we're using the area scale factor, and we get an area of 80. Okay, the other way people like to approach these questions is via ratio. So we know the ratio between lengths here is 5 to 10. And that's between shape A and B, and that simplifies down to 1 to 2. Okay, so for lengths the ratios are 1 to 2. For area it will be this ratio that we've just figured out squared, so that would be 1 to 4, and volumes will be this length scale factor cubed, so 1 to 8. Okay, so similar, very similar, same method really, but just presented in a slightly different way, and then you would use the ratio to then find the new area. Okay, on to the next one. Zane buys mineral water in large bottles and small bottles. The large bottles are mathematically similar to the small bottles. Large bottles have a height of 32 centimetres and a volume of 2,000 cubic centimetres. Small bottles have a volume of 500 cubic centimetres. Work out the height of the small bottle. Okay, so what we can figure out from this is the volume scale factor. So I'm still going to write down length scale factor, area scale factor, volume scale factor. But this time I'm going to work out the volume scale factor first. How many 500s go into 2,000? Okay, and hopefully you know that's not too bad. Times by 4. So therefore the length scale factor is the cube root of 4, and the area scale factor will be the cube root of 4 squared. Not that we need the brackets. Okay, work out the height of a small bottle. So that's a length, height is a length. So we need to do 32, and we are dividing by the length scale factor here, because we're going from the larger bottle to the smaller one. 32 divided by the cube root of 4. Let's use a calculator for that. So we get 20.2. So 3 significant figures. 20.2 centimetres.